I think I showed you before that you need to start with the etch registration markers. This is what the chip looks like before it goes in the STM. In ultra-high vacuum, heat up to high temperature, reconstruct the surface. You bring down the hydrogen onto the surface. That forms the atomic scale mask. You come along with your STM tip and you deliberately desorb just 6 hydrogen atoms from the surface. You dose with the phosphine gas. That brings a phosphorus atom in. That's going to be the active component. And it only sticks where that silicon is exposed. We then do a controlled chemical reaction. So we heat it up. And what we find is the pH2 likes to grab a hydrogen and come off, allowing space for another pH2 to dissociate to pH. We heat it again, another pH2 comes off. And now if we heat it just a slight bit more, we find that the phosphorus atom goes into the top layer and it kicks out the silicon. And the silicon stays above it, so you know where it is in the surface. We now take this device and we encapsulate with silicon, so that we basically form this nice protective environment where that phosphorus atom is sitting beneath. That's the full 3-dimensional encapsulation. But interestingly, not just do we put the atom in the middle, but we also open up these leads at the same time. And these leads have very heavily phosphorus-doped silicon, and that allows us to bring those wires, the current, through to the actual atom itself. Once it's encapsulated, you take it out of the UHV and you make contact to the buried device.